Hello, let me introduce myself. My name is Lori Brown and I work for SQLRx, which is a division of ISI in Dallas. My company specializes in finding and resolving SQL Server performance issues, as well as providing SQL Server DBA assistance and mentoring. I'd like to speak today about predicting SQL Server performance by leveraging ReplayableTrace with SQL Profiler. We've developed a methodology that we currently use to predict performance and hope that you'll consider using it as well. I'd like to quickly go over some of the reasons to perform this type of analysis in case you might not have thought of some of them, as well as show you the tools and methodology that it takes to accomplish it. I'll also show you a small example of our findings to give you an idea of how this can focus your efforts and save time and money. And then I'll sum it all up and let you know how to contact us with any questions. My focus is specifically on SQL Server performance and a way to analyze requests sent by applications to the database tier. Just so you know, this is part 1 in a 3-part series. Part 2 is a live example that I will be giving that shows starting a replayable trace, collecting data, and analyzing it. Part 3 is a demonstration on how to debug and step through code being optimized. Jeff Schwartz will be presenting that subject, and I think it's something that you'll want to see. So, why would you want to predict performance of the application or code that you're developing? I mean, you write perfect code, right? But while your code may currently perform well, there are new versions of SQL Server that are being written and tested as we speak. Are you ready for them? I regularly work with ISVs who have not yet certified their code will work even on SQL 2005. They're either still using SQL 2000 or running on SQL 2005 and 8.0 compatibility. They've not even thought about 2008 yet. The problem is there's lots of legacy code in most applications that has to be tested with a new version of SQL, and it's a time-consuming process finding all that code that doesn't play well. I've also worked with ISVs who have new customers who want a hardware recommendation. How do you know what to recommend when that subject comes up? Then once customers actually have their hardware, they always want to know how to optimally set things up. I'm usually consulted on how to optimally configure the database server. One nice thing that I have seen are ISVs who give a good, better, and best recommendation for hardware and software purchases. This makes their life much easier as well as the customer, and I can tell you it's a really nice thing to be able to get as a customer. As an ISV, there's a lot of things that you have to prepare for. There are new versions of SQL every 2 years, as well as the service packs and hotfixes that can be possibly installed, and those can compromise how SQL performs. It's a lot to watch out for. There are new types of servers that are always coming out. There are new types of processors like hex core and octa core, and all of those have some known issues with SQL Server installs, and all the various disk subsystems that are available that need to be addressed. So through all of this, you are charged with making sure that the product you sell performs well. And just as any company in today's tough business climate, you have to make sure that you keep your costs down as you work. The good thing is that there are tools available to help. Some cost nothing and some cost quite a lot. And while the higher cost tools like LoadRunner are industry standard, they can also take a while to be able to use them really well. There are tools that are freely available from Microsoft that can be used to accomplish this exact same thing. My preference is SQL Profiler with a replayable trace. The best thing is that Profiler comes with SQL Server and it's free. A replayable trace is a SQL trace that comes with SQL Profiler and is designed to capture all of the requests or the workload being sent to SQL to a trace file that can be replayed. The beauty of this is that you can take this workload to another server or SQL instance and can deeply analyze the performance that you find. If you have performance data from the original environment, then you can compare data and know what will perform better and worse. And you can replay that workload as many times as you need to test various scenarios. So here's where you get the template from. You get the replayable trace template from SQL Profiler. If you start up a trace in Profiler, one of the templates you can select is pSQL Replay. And here are the events that are captured. I've learned that you have to have these very specific events, and you shouldn't alter anything about them. To save this in a form that can be started on a job, you actually have to start the trace, and you can do this on your local computer, and then export the trace definition to a SQL script. This is what the script looks like. You can set the location and size of the trace files collected, as well as how many files that you will ultimately collect. Simply run the script in a query window to start it. And it's a good idea to write down the trace number so that you can stop that trace later on. You should be able to download a ReplayableTrace script from MSDev and from our blog at blog.sqlrx.com, and I'll give you a link to that later on. So here are the basics of how you make this happen. You need access to the different environments that you want to compare. You have to make a backup of the database just before you start capturing your workload. It's very important. And this is so that you can replay the workload against the database again with all the data at its exact proper starting point. Then you capture your workload using the trace replay script that I just showed you. It's good to have your matching logins from both environments, so you may need to script out your logins. However, if this is not doable or important, I can discuss a workaround later. Once you've captured your workload, you take everything over to the new environment, you install your logins, you restore your database, and you start the workload, and voila, you capture your performance data. So here's how ReplayableTrace. I've got a flow to help better visualize what we do. The first thing you want to do is capture your workload from your production environment. This is how I normally have to work. We have to capture our workload from someone's actual production. So we take a backup of the database or databases, it could be more than one, and then immediately starting collecting data using the server-side trace script that was generated for the correct version of SQL Server. So if your production is SQL 2000, you have a SQL 2000 generated collection script, the same as 2005 and 2008. So once you've gathered all the data and are ready to analyze, you take your copies of database backups and trace files to what I'm going to call a test environment. This is the new environment that you want to run your workload on and compare the performance. Now, notice that I have a step to perform a control run. So that I can compare apples to apples in performance, I need to first capture performance data using the same equipment. So I create an install of SQL and everything else as it is in production. The performance data captured can be as simple as only a SQL trace, or it can include a lot of SQL metadata like file stats and dynamic management views and OS performance data or perfmon. Once that's all done, we install the new version of SQL, OS, and anything else that will be needed in the new environment and perform another replay of the workload. While once again you collect your performance data. Once we have all the data collected, we take the performance data and compare. This way I can see if queries can take more or less time in the new environment. If I collect perfmon data, I can see how memory or the disk subsystem handles each workload. This will let me know if I need to beef up my hardware. Once I have my comparison, I can work to make code optimize for the new environment and prepare to release this code to a production environment. This would be just like you handing a new release to your customers. I can use this method over and over again since I can constantly restore my database back to my starting point, apply changes, new index or more beefy hardware, and replay that workload one more time. I'll capture and compare again, and I keep doing this until I have a test run that produces the performance that I'm looking for. As ISVs, you want to use this method to tell customers that you support specific versions of SQL Server with whatever service pack. In preparing for new releases or updates, you can test tuning strategies to see if new indexing helps, and you can more easily debug your T-SQL as being sent based on normal use of an application's GUI. Debugging will be covered in Part 3 of this series by Jeff Schwartz, and you'll definitely want to see how he does that. Sometimes the exact way a user really uses an application is really difficult to reproduce, but by capturing everything that's sent in from the trace, this would capture all the parameters and the exact order that a user does things for you, and that way you can just replay exactly what they do. Don't limit your performance analysis to SQL. I highly encourage you to collect Windows perfmon stats. You can find what hardware, amount of memory, RAID type, types of disks and processors that are best for your application. And to do this, you can definitely rent some time with Microsoft Test Center and try different types of hardware. And that way you can know if certain operating systems such as Windows Server 2008 with or without Hyper-V, which is really coming into play, have a positive or negative effect. And finally, you can use the performance data as a way to have a baseline of performance so that when you're working with your customers, you'll know if issues they are describing are really and truly an issue or not. So there are times when ReplayableTrace is not the best method to use. Schema changes will break the workload replay, and schema changes as in changes to tables, new or changes to columns, link servers will cause errors, and unless you're able to set those up in the new environment too. So here's my list of some gotchas that we've run into. One thing to keep in mind is that the workload can be loaded into a SQL table and altered to fit your new environment. You can change database IDs and the logins, and the reason is you need the logins is so that you can make sure that users or groups have permissions to run the right thing. If this is not something that you want to consider, you can change the workload so that all logins are actually SA instead of whatever login that may have been captured from the production environment. That way, no statements will fail. You don't take that chance, you capture everything. This way you don't spend time chasing after errors that really should have never been generated. And if you're really good, it's possible to change or add SQL statements to your workload and play those changes in the new environment. We've found that if you're comparing a new version of SQL Server, that it's best if you update statistics or rebuild indexes before running your workload. And you need to expect the workload when replayed to consume a lot of resources on your new environment, and this is because it shoves everything in as fast as it can. When you analyze your performance data, especially the queries, we've found that duration is not always consistent, and it's best to usually compare your reads, writes, and your CPU use. And finally, you need to expect to have to replay your workload many, many times to get it right. It seems like every time I think I've seen all the gotchas, a new one will show up. You know how that works. You can compare your query performance by capturing a SQL trace of the workload playing. This trace usually collects completed events, errors and warnings, and any other information that you might think is useful to tell you how your SQL is performing. If you want to find the causes of your errors and warnings, you'll need to collect all the starting statements, and this can produce some really large trace files, so plan for adequate space when you do it. Once you have your performance data collected, you pull it into a place where you can analyze it. We pull our SQL traces into tables and clean up the queries so that they can be grouped. The reads and writes and CPUs can be summed. I've given you some of the parameters that you need to clean up, or actually the way that you clean up parameters, and we substitute certain things for strings and numeric values and date time so that it makes it more generic and can be grouped. You can also pull your perfmon data into tables for ease of comparison. Once you have your queries grouped, it's really easy to compare everything. So here's an example of a comparison that we've done for an actual client. We had a client who wanted to upgrade from SQL 2000 to 2008. They wanted to know of all their homegrown code what needed to be changed so that it would run well on 2008. And it's a really good thing that they did it, since we found that if they had not, they'd really regretted it. Their batches ran over 70% slower on 2008, so they needed to work really hard on cleaning up their legacy code. So it was up to us to help them out. So since we had everything gathered up, we grouped and compared them, and we provided them the exact batches that were misbehaving and behaving well, as you can see, so that they would know what stored procedures or statements they needed to focus their attention on. You can see here that USP Proc1 has some real issues, but USP Proc10 got a great big performance boost from 2008. And you'll find this is really common. Some things will work really, really well in the new version, and some things will work really, really terrible. And it's really good to know which ones are which, because they can actually mask each other so that you don't know that you have actually suffered a bad performance hit. Now, since we captured all the statements performance, we can then tell our client that very specific statements inside of the stored procedures are the ones that need to be worked on. This saves a lot of time, because you know that there can be thousands of lines of code to some stored procedures, and you can spend a lot of time sifting through them trying to find the exact piece that's the misbehaving part. This comparison allows you to focus your efforts on really bad or legacy code instead of trying to reinvent something that already runs well. So if you know what performs really well, you can look at the good code, as in USP Proc 4, you can look at the things that run well and compare those methods used to the bad code. So that will help speed your optimization efforts. I also wanted to show you that you can know how many times errors are generated, so you know which ones are pervasive. You should really work to eliminate error messages and not just think if your application suppresses these messages and the user doesn't know that they're there, that all is well. That's just not the case. An application that causes SQL Server to constantly throw error message places a load on SQL that is totally unnecessary. I've worked with developers who seem to not really appreciate this fact and have had to enlighten them on the subject. Checking your errors is becoming more and more important because newer versions of SQL Server seem to have a much tighter enforcement of T-SQL syntax. So code that used to not error before can all of a sudden start to do so, and if your application's suppressing it, no one will know. So if you collected your starting statements, you can find the cause of the errors and work to eliminate them. Once again, this is all about focusing your efforts. From this, I can see that USP Proc 22 is causing the bulk of the errors, so I know to focus efforts there. And you can also find code that's being deprecated. All of those messages are generated by SQL, so updating to non-deprecating code can remove stress from your SQL Server. This is much like removing your errors. Well, by now you should have a really good idea of how the replayable trace could help. You should be able to see that it's fairly easy to do and doesn't cost anything to use. So, to wrap everything up, ReplayableTrace is a powerful tool to take advantage of. With a little bit of planning, you can analyze and compare your performance between your different environments and give this to your customers as good information on what they can expect from your application. If you're preparing for a new version of SQL, this method allows you to focus on what really needs optimization. And using this method, you can make hardware recommendation that allows your customer to have access to information that will make their lives easier as well as you, and will give you a really good reputation. I'd like to encourage you to join us for part 2 of the series. There I'll show an actual workload being replayed and some techniques for comparing performance data. So, just like you're working for your customers, we're available to work for you. You can contact either me or Jeff Schwartz with any questions. I invite you to take a look at our website, SQLRx.com, and check out the information and services that we provide. And I also blog a little bit with some tips on how to resolve issues that we've run into. I try and keep it to the interesting things. And I'll have scripts out there for download. Thank you for watching, and I'll see you again in part 2.